record on the and start sharing the screen. So today we will start with a new topic about Java collection. And if you recall, previously we learned a couple of new data structures that in this course. We start with a stack. We start with a stack, and then we discuss a queue. And then we also discuss a linked list. And before we even start with the stack queue, we also learned array, is it? And not array list. And I believe in your assignment you also did DAC. Is it? So quite a number of data structures we learned, is it? And the Java has a library. It's or we call it a framework. It's a Java collection framework. Okay, framework. And previously when we discussed stack, queue, linked list, and array list, we also discussed how we can just directly use the corresponding library from the collection. Is it? So today let's take a look at the hierarchy of the collection. Hierarchy of the collection, and you can see over here, so this is hierarchy, it's horizontal, okay? So the top hierarchy, you will see it's a collection. Is it? Previously when we learned, you also remember you can also include the collection, is it? And all over here, if we take a look at this slides. This slide is also available on our course website, okay? So you can download it and review it later after class. So the left part, it's all interface, okay? So the collection, basically it's an interface, okay? So just remember that. And we also previously, I remember I also show you how we implement our own list interface, is it? So over here, basically in Java collection framework, it also has a list interface. Remember, it's an interface, okay? And the queue is also an interface. And DAC is also interface. So all over here are interface, okay? And for interface, you remember, it can have three kinds of methods. Is it non-implemented method? Is it default method, and static method? Is it? So we learned of those. And this part we haven't learned, is it? And this part, if you are going to take CS3, so CS3 is supposed to cover those. And the next, let's see, and between these two vertical red line, this part, it's all abstract class. And basically, we didn't use them in our previous discussion, okay? Just some abstract class, so they have some method not implemented, is it? And then on the very right, it's collection concrete class, is it? Concrete class, linked list, we already learned. Array list, we learned. Is it? Stack, we learned. Is it? And generally speaking, those hash related stuff and the tree, those you will learn in CS3. And the hash concept in our one of the lab, we kind of know the basic idea. It's a very useful concept for hash, okay? So hash, is it? So, hash. Hash concept is basically, we call it many into one. To one concept, okay? So you can, previously you remember a word, a long word, but you can hash it with to some single number, is it? So that's quite useful, okay? So you will learn that in your CS3, and this week we are also going to cover priority queue, okay? So that's the general structure of the Java collection. And let's take a look at the next slide. So this one, okay. And previously, you remember when we discussed the implementation of a linked list, we also discussed, you remember, quite a useful concept, iterable interface and iterator interface. Is it? Basically, you can see from a Java collection framework, these are also within the framework. And if you take another close look, you will see. So iterable is basically kind of the root level, is it, of the hierarchy. And below it is a collection, is it? And below it, we have list and something else, is it? And we also previously learned iterator, is it? And the iterator, iterable interface, it has a function called iterator, is it? And the return type is an iterator. It also has a method called for each. Is it? We also discussed that. That's quite useful. Is it? And for iterator, the nice thing for it is it has the three methods. I call has, next, and remove. Is it? Quite useful. And the collection, if we take a look at the collection, and if you recall previously when we discussed our own version of the list interface, you remember that interface also contains quite a number of methods. Is it? Like over here it shows add, is it? And contains, is it? And remove is empty, is it? And size and string. String we didn't discuss, but we showed in some of our examples. So you can see all of those methods that previously, they are also part of this Java collection interface, okay? So whoever in this hierarchy diagram, is it, for the sub-concrete class, so you can create your own concrete class, is it? From this hierarchy, is it? Then inherently, that concrete class can support all of the methods mentioned here for the collection. And another concept here, and why we call it a collection, is it this interface, okay? It's an interface. We call it a collection because why? Because it represents a group of ordered items, is it? Ordered items, is it? And you can do something on it, is it? So basically it contains all sorts of, we call it ADT, is it? Abstract data type, is it? Yeah, so it's a group of data structures, okay. And the next, let's see, there are a couple of things. So list interface, basically we discuss our own implementation, is it? Of the list interface in our linked list example, is it? So over here in Java collection framework, the list interface over here says it basically stores a group of items in a sequential order, okay, in a sequential order. And it will allow you to specify where you want to store, is it? And you can also access elements by index, is it? That's why you remember we discussed the linked list. So both in the collection framework, linked list and array list, is it? Both are in the hierarchy as a concrete class. Concrete class, is it? But all of the features was a list provided, is it? So that's why both of them it says allow user to specify where the element to store, is it? You can store, you can do add, is it? You can specifically add at where index, is it? Or you can just do add, is it? And you can also access, is a get, is it? And previously we also discussed the difference between these two, okay? This linked list is more efficient if you have a lot of insert and remove operations, okay? For array list, if you need a lot of access anywhere, okay, then you choose array because it's array, is it? That's what the name comes from. So array is it's index. That's its advantage, okay, array. And linked list, the name, the major part is the linked concept. Is it because it's linked? That's why it's good for insert and remove anywhere, okay? So that's the concept here. And then over here to also list the list interface, the major operations, is it? You can see it has support add all, is it? And we will see in our example. And the get, is it? Index of, is the last index. And also, we will also see the list iterator, okay? So not just iterate as listed, and also it support remove and set. There's quite a number of very useful operations. Okay, so there is another concept we are going to see in our example. It's called a list iterator. Okay, so and you remember that list interface, is it has a list iterator you can use. And list iterator, the difference between the regular iterator, is it? And the regular iterator is you can only do forward, is it? Because it only has a has next and next, is it? Only has, so moving in one direction, is it? And the list iterator, if you take a close look, you see, it also has previous and previous. So on top of the moving forward, is it? It also support what? Support backwards. Okay, so list supports list iterator, just be careful. This list iterator interface also supports what? Supports backward and forward. Okay, so supports you do the iterating in both direction, okay? And for the regular iterator, okay, regular iterator, only forward advancing. So be careful about the difference here, okay? So that's regarding iterator and the list iterator. And then next, okay, array list we already discussed, is it? So here, just let's take a quick look about its hierarchy, is it? And of course, is it, you can see, and on the very top is iterable, okay? So everyone is from iterable, is it? And then you have the collection interface, is it? And iterable, it means it can advance, is it? It supports advance, is it? And the collection, the purpose for it's a group of items, is it? So store a group of items. That's its purpose, is it? And the list, then it's a sequential. So be careful, okay? Because later on when you will also see, you will also learn another concept in your CS3, it's set, okay? That's a different concept here. So list, then it's not just a group. On top of it, it needs to be sequential, is it? You can do forward, you can also do backward, is it? That's called a list, okay? And previously we learned array list, is it? And the nice thing for array list is you can, it's focusing on the indexing, is it? So easy to, so quick access. Is it using indexing? That's its advantage, okay? Okay, then let's take a look at the linked list. Is it the same thing, linked list? Is it a concrete class? Is it? And from iterable interface, is it? And it supports add and remove, is it? And the plus and the remove it is the front and the back. So that's why you remember when we discussed queue, is it? Queue in the collection framework. In collection framework, it is an interface. Okay, so be careful, it's an interface. So when you really want to use a queue object, then what you needed to do? You needed to use a linked list, is it? Linked list, is it? That's what we do, is it? You do queue, is it? Suppose integer. Is it like int queue? Is it? But when you do new, you cannot do new queue. Is it? You cannot new an interface. Is it? What you do is you do new linked list. Is it linked list? That's how you create an object. Is it? But you want it to have the feature of first in, first out. Is it? You want to make use of that part. Okay, so that's the idea, so linked list. But the major thing for linked list is it's easy to create, so that you can do numerous insert and remove. We will discuss this in our example, okay, comparator. That's also very important concept. The collections class, maybe we will, let's just quickly mention this, and later on in our example, you will see it's clearly. And be careful, okay, in the collection framework, there is a class, specific class. So be careful, this is different. So we have collection. This is an interface. And what over here is called collections. Okay, and it's a class. Okay, but this class is very specific. Okay, it only contains static methods. Okay. Static method. So what it's basically its purpose is to support a number of algorithms, so that you don't need to reinvent from the wheel. You can just call that method in this class and go ahead to use it. And what it does is it has a method, suppose called sort method. Is it? The sort method. And then the sort method, you can plug in some specific data structure, ADT. So you can plug in some ADT, and over here it provides a general static method, and you can plug in some ADT object so that it can do the sorting for you, okay? So that we don't need to specific for each ADT to write a sort method. So that's the concept. Later on, we will see it's quite useful, number of methods. So that's a collections class, okay? And here it provide, you can see it provides sort, is it? And also it provide a binary search, is it? Reverse, the shuffle, is it? Minimum, maximum, quite a number of methods so that you don't need to reinvent, okay? Okay, so this is the concept of the general idea about collections. Next, let's take a look at an example, okay? Okay, so what over here we need to discuss is that generic method. Okay. So over here, we are going to discuss how do we use the collection, okay, framework. So application, app on collection framework. So the first example we are going to see is array list and linked list. Basically, both we already learned, is it, and also quite familiar. So here just gave us a review kind of and related with the collection framework, okay, in this big picture. And as usual, I don't remember, have we ever discussed the book class? I'm not sure, I don't remember. Okay, anyway, this book class, it implements clonable and also comparable interface, okay. And it has ID name, quite straightforward. It's get name, get, okay, set, quite, and implement the clone method, to string, and compare to method, okay. So here to implement the compare to method. So just based on ID, is it? If ID is the same, then it's going to use name for comparison, okay. So that book class is quite simple. Oh, it's already in the main. Okay, then let's see, how do we use it? Is it, so this first part is quite straightforward, is it? We create array list object. So over here, it's array list object, or we call it an instance. Is it instance? The name is called what? Array list. Over here, the type we use list. Is it interface? That's allowed. Is it because array list, the relationship between it, it's the subclass, is it, of the list interface? Is it? So in the hierarchy, is it in the hierarchy relationship? And then we can just add a bunch of number here, is it? And you can also specify where you want to add, is it? And then we just output this array list. So nothing new here, quite straightforward. And then what next? Let's see. The next part is we create a linked list, is it? And this linked list, the type is object, so very general. That this time we didn't use list, we use linked list itself. Let's create new links, and we use that array list that we just constructed to initialize our linked list. That's also fine, okay? And then in this case, because you see this linked list, the type is object, is it? And the previous array list, that's an integer one, is it? And over here, you see, when you do add for this link, it's add string, is it? So this is allowed because over here it's object, and both integer and string are subclass of object, so that is fine, okay? And we can call add, we can call remove, is it? And add first, just to show different different method here. And what next part? Let's see. The next part is try to show the linked list. You remember previously we said the list has a iterator called list iterator. Is it list iterator? And it's also interface. Is it interface? And that interface is from iterator. Is it? So then you have this list iterator. So that's the hierarchy relationship, okay? So, and previously we also mentioned this, later on we will see, and it will suppose both directions iterating, is it? So anyway, here you have this list iterator, and you get that linked list where to start. Basically, it's a starting cursor, is it? It's a starting cursor. Okay, so that's where you start. And then you're going to try to move to next. Is it to find where the next item is it? And if you find a certain item, then you can remove, is it? And this will work, Okay, so the loop won't be terminated. So loop will not be terminated if we use iterator. Okay, but over here, okay, if I write this regular for loop, be very careful, okay, this for each loop. If we use this for each loop, and within the for each loop, you do remove. You try to remove. You try remove, is it? And if you run, you will see it will throw concurrent modification exception. So it won't allow you do that. Okay, so be very careful, okay, when we do the loop with of this data structures. So this is not allowed. So just keep this in mind. So in case you have a lot of insert and remove operation, is it? So the scenario, the cases, is if you have insert and remove, okay, within a loop, is it? Then you better use iterator. Okay, not for each loop. It will cause trouble, okay? And you can try to run it after class. You can uncomment this part of code and run it. You will see that error will be thrown. Okay, and when you do that, make sure you comment the previous part. Maybe I can show you. Okay, let me try to show. Let's do this. I comment this part out, and then let's uncomment this part. Then I needed to also comment this part because it also involves that iterator. Okay, and let's see. I'm going to run it for you. Did you see? It will cause that concurrent modification exception. So that won't be allowed. But before that, it runs perfectly, is it? And also over here, you see that. So this is our array list. That's integer. Is it? And this one, it's object. Is it? Because the type is object. That's why you have both string and a number. Is it? Both string and integer. So over here, this example just shows us if you want to have a kind of a linked list, its type is not that specific, it's some comprehensive type, then you can use object to do it, is it? So I just showed this won't work. This will cause trouble. Okay, then let's uncomment that other. We use the iterator. But you see, if we use the iterator, it runs perfectly. Okay, we can run it and see the view. Did you see it runs perfect all the way to the end of the program? As it nothing get stuck. Okay, so so just be careful over here. Okay, I just mentioned. And then let's see the other nice part for list iterator. List iterator, is it? I said it's support forward, is it iterating, and it also support backward. So both way, okay, both direction. And if you wanted to move backward, is it? You can start like over here, your iterator. Where do you start? You can specify the list iterator where it is it? Because here it says start at back. Is it reverse way? Is it? Then in this case, you can call has next or has previous instead of has next and previous. Okay, so it's supposed both direction of iterating. And what next part to try to show us is we can also create an array list with some object. Is it in this case is a book? Is it? So we add some book. Is it? And then we can see the book output. Is it? And it's unsorted. Is it? So let's see the book. The book. Okay, over here we have the book. Is it? So it's follow whatever the order that you add the book. Okay. And then next, let's see. I can do this kind of. Okay, and then over here, if you take a close look, be careful, okay? Over here, it's called collections. And then the sort method, okay? This collections, you remember previously we discussed, is a class. Okay, it's a class. And this class has what? All sorts of static methods. Okay, the static method's major goal is to provide number of algorithms, okay, so that you don't need to write on your own, okay, reinvent from the wheel. So for this method, what it does is going to do sorting. Is it? Sort what? It's a plug in. It plug in an array list. Is it? Array list object. You can also plug in with like a linked list, some other data structure. Then it will sort for you. Okay. And over here, this array list, and why the sort will work, it's because of a book. Is it already implemented? The comparable interface. Okay, the comparable interface. Here there is another very important concept because later on we are going to see another way to do comparing. Okay, normally if a class implements a comparable interface, we say that class follow, we call it nature ordering. Nature ordering. Okay, so like 1, 2, 3, 4, 5, is it like a number, this kind of A, B, C, D, is it lexicographic ordering, is it, we call it nature ordering. But of course, over here, we define whenever you want to use that class implement a comparable interface, then you must override the compare to method, is it? So compare to it's always compare. Also be careful, okay, compare two objects. Okay, so over here, you're going to compare what? Compare B with who?
Yes.
So who remember this? That's a good question. Let's see, okay. I'm going to clear this, stop sharing. So let me ask you not sharing. Let me ask you a question. So that compare to, is it? And it has another object. We call it some book. Is it a book or something? Is it something? Is it? So my question is something compared to who? In our scenario over there, what is the, if you write that Java code, it will compare to who? So who knows this answer? I will give you extra bonus. So bonus point. Okay. So who remember what is that? So when we implement in the book class. Yeah, very good. Okay. Yeah, so remember it is that special keyword this. Okay. So it is what? It is object itself. Is it? Itself. Okay, very good. So still remember. Okay. Okay, let's go back to our. Okay, so basically over here, what is going to compare? It's going to compare the ideas of whose ID. It's this dot ID. Is it? Name, whose name? This dot name. Is it? So because this compared to belong to who? Belong to who? It belongs to that who is who? Is this. Okay, so remember this concept, okay? Okay, then let's take a look over here. There is another new concept today we are going to see. So there is another interface for comparing. It's called a comparator interface. Okay, and here we define a class. We call it a sort by row something, is it? And we said this class implements what? Implement this comparator interface. Okay, this comparator interface, it has one method that you need to implement. It's called compare. Okay, and this time, this compare, it has two parameters. Okay, versus that compared to only has one parameter. Is it one? Here you have two parameters. So you're going to compare these two objects. Okay, compared to this two objects. And over here, I'm going to compare their ID. Is it? Over here, let's see, continue see, okay. And then next, I define another one. I said, okay, this time I'm going to sort by name, this class. And this class implements what? Still comparator. Okay, so it's going to implement that compare method. It compares what? Compare string. Okay, the name. And then let's see, we have another class. We call it a customer sorting comparator. And it implements what? It implements the comparator. And this time, this compare method, okay, let's see, it's quite comprehensive, is it? First, we have an integer, we call it name compare. It compare these two parameter. Parameter one's name with parameter two's name using compare to, because compare to a string class support compare to as it, so you can directly call compare to compare. Okay, it will give you a negative or 0 or 1 is it the return value. And then we also define an ID compare, is it? So you can use the ID to compare to ID to integer, is it? To integer. And then you can define, is it? Use it to compare, because if the name the same, then you said I'm going to use ID for my comparison, okay? So that's the concept here, okay, concept here. Okay, then let's go back to take a look this part. So previously we said we use the, I need to do, the sort, where did, oh. Okay, previously we call the collections the sort. This sort just has a single parameter, is it? It's some collection object, is it? You do the sorting, okay? And then let's see over here, another sort. This time still collection sort, is it? The first is some ADT, some data structure. But did you see the second parameter this sort is some comparator object, is it? We shouldn't say comparator object, is it? So it's some class, is it? Implements the comparator interface, is it? Okay, and then you plug in some object, is it? Because I said I'm going to call that new sort by row, is it? That is a class, is a class, and it implements this comparator interface, is it? So here the idea is the collections. Within collections, a lot of its method, the static method, okay, they take some parameter, it's some comparator type. Okay, so it's going to be very flexible in this case. It won't just require your class to implement that comparable interface. You can redefine whatever comparison you want to use. Okay, so that's the nice thing. So this is not, so over here, we call it nature ordering. Nature ordering. This is not, is it? This is user defined comparison. Is it? So your object, so once you have this, then your objects doesn't need to definitely implement that nature order. So you can redefine a new way for the comparison. Okay, so that's the nice thing part, because not all of the class needed to define that comparable interface, is it? So if that case, can you still use the algorithm from collections? Of course, you can still use that. Is it? In this case, you just need to define the way you want to compare. In this case, you said, okay, I want to sort by ID, is it? And after it, then you will see the result is sort by ID. And next you see, is it the same sort? But this time I said, okay, I don't want to sort by, I want to sort by name, is it? It's very flexible, not like if you do nature order, it's also only one approach. Or we say one criteria, is it? For comparison. For comparison. Is it? Over there, it's first by name, is it? And then by ID, is it? But you may, in the real world scenario, you see, if you have the data structure, is it? A lot of time when you do sorting, you say, oh, I want to do sort ascending or descending, is it? Or sort by date, or sort by amount, or sort by size, is it? A lot of internet app, is it? You can do, or you can select whatever way you want to sort, is it? Then in that case, you see, if you just use nature ordering sort, it won't work, is it? Then the way, that's why the collections, is it? This class is sorting algorithm provide you with flexible. So this is flexible sorting, is it? So you can define your own criteria for sorting, okay? So that's a major concept here. Then you say, oh, we define some other sorting. I will first sort by date and next sort by amount, is it? So you can do all sorts of sorting. That's the key point here, okay? And the next part is pretty straightforward. You just add. And you can do add or, is it? So the add or, It's also from collection. Is it collection interface has the add or method defined? Is it is just array list implemented also? Is it so you have array list AR? Is it now I want to add the second array list to the first one? So it's kind of you concatenate both array lists together. Okay, so that's the idea over here. And I think we already run out of time. Okay, so so I think that's all for today. So tomorrow, yeah, tomorrow I think I should be able to finish off the collections. And then Wednesday, Wednesday, Thursday, we're going to go over secure programming. And next week, like I said, I'm going to give you some interesting topic, but those will only be on the bonus part of our final exam. Okay, and so we will need to finish today. So can you all just send your name to the chat as usual? And then I'm going to see you all tomorrow.